Have you ever stopped to ask, what is sleep? Why do we spend a third of our lives unconscious in bed? For centuries, sleep was a mystery. Ancient Greeks believed dreams were messages from God. In medieval Europe, people even slept twice a night, a first and second sleep. Today, in a world obsessed with productivity, we often treat sleep as optional. But science tells a different story. Sleep is vital to our health, from our brain to our heart. So let's dive into the physiology of sleep and the latest research behind it. If you guys are new here, hi, my name is Nisha. I'm an internal medicine resident, passionate about preventative care and lifestyle medicine. Without further ado, let's dive in. Sleep is a biologic maintenance mode. It restores every cell, tunes our memory, and balances hormones and strengthens our immunity. Chronic sleep deprivation, it's linked to memory loss, depression, weight gain, and heart disease. One landmark study showed that sleep deprivation impairs emotional regulation, increases anxiety, and weakens memory consolidation. Sleep will literally protect your mind. Sleep is orchestrated by several key brain structures. The first is the suprachiasmatic nucleus, or SCN. This is essentially your internal clock. It reads light from your eyes to sync your sleep-wake cycles. Even those who are blind can sometimes maintain this rhythm through this mechanism. Another structure is the thalamus, and this relays sensory input to your cortex. And this is thought to be why we dream during our REM sleep. Another structure is the basal forebrain. This builds up sleep pressure with adenosine. Adenosine is a byproduct of metabolizing ATP, or energy. In other words, it's a byproduct of us being awake. And the longer we are awake, the more adenosine will build up, causing us to feel sleepy. You might notice that you have better sleep on days which you work out. And a theory behind this is that when you exercise, you burn off more ATP and therefore have a higher buildup of adenosine, which is why you feel so sleepy at the end of the day. Furthermore, caffeine will block the receptor of adenosine, which inhibits your body's ability to sleep if it's taken later in the day. The final structure is the pineal gland, and this releases melatonin in response to the dark. And melatonin is essential in helping you to fall asleep and stay asleep. And since caffeine blocks adenosine receptors, now you understand the physiology of why that afternoon cup of coffee will keep you up at night. So now let's dive into the concept of sleep cycles. So sleep isn't just one long phase, it's actually a series of repeating cycles distinguished on an electroencephalogram, or EEG, which measures your brain waves. And this is a tool that's used in a polysomnogram, which incorporates other variables like your body temperature, your eye movement, your heart rate, respiratory rate, in determining what phase of sleep you're in. So stage 1 is light sleep. Stage 2 is also a form of light sleep, but the brain waves depict spindles and K complexes. Stage 3 is deep sleep, or delta wave sleep. And this is where your body will repair itself. And the last stage is REM sleep. And this is where you dream, have emotional processing, and memory consolidation. One cycle is about 90 minutes, and this repeats about 3 or 4 times per night. And before we move on, I just wanted to touch briefly on the use of sleep trackers in this day and age. So there are numerous commercial devices designed to track your sleep nowadays. And I've also tried out some of these apps, and they're very exciting. However, their accuracy is controversial. Research supports that these devices can accurately predict your sleep onset and your duration of sleep. However, they cannot reveal your sleep stages because this relies on detecting brainwave activity, which is done via an electroencephalogram, or EEG. And this is the test that involves sticking electrodes on your head to monitor your brain waves. These devices use other tools to surmise what stage of sleep you're at. And these are things like your heart rate, your respiratory rate, whether or not you're snoring, etc., etc. Furthermore, there has been a rise in a condition called orthosomnia, and this is when there is too much anxiety in tracking and perfecting your sleep data. In this case, it's important to focus more on how you feel after a night's sleep versus what the computer data shows. Now let's chat about circadian rhythm and screen usage. So our circadian rhythm is a 24-hour biological clock. This keeps us synced with day and night. The suprachiasmatic nucleus, or SCN, will read light cues in our environment, which regulates melatonin release from our pineal gland. Artificial light, especially blue light from screens, will delay melatonin secretion and will disrupt your sleep. One randomized trial showed that reading tablets or using your iPad before bed will suppress this melatonin secretion, which delays REM sleep and reduces alertness the next morning. So the key takeaway here is to avoid screens an hour before bed. And I say at least an hour, but ideally 2 to 3 hours, in my opinion. To better understand sleep, let's discuss 2 key systems that control when we feel awake and when we feel sleepy. These are process S and process C. Understanding these will explain why sleeping in after a rough week will not fully fix your sleep debt. First off is process S. This is known as sleep homeostasis. Think of this as your body's internal sleep pressure system. The longer you're awake, the more pressure builds up, which pushes you towards sleep. And this is partly due to accumulation of adenosine, which is the chemical, as I mentioned earlier, that will make you feel more drowsy the more it builds up. If you skip sleep, your body starts to create what we call a sleep debt, which is kind of like a financial debt. It has to be paid back eventually. But here's the catch. You can't just erase that debt with one long sleep-in session. This will actually have to be recovered in several nights of deep sleep. Research shows that after a bad night, your body tries to recover by increasing your deep sleep, which is in stage 3, and REM sleep the next night. If you've racked up multiple nights of poor sleep, it'll actually take several nights of solid sleep or good quality sleep to fully recover, and not just one lazy Sunday morning. So this makes a lot of sense, especially if you're like me and just finished working 7 nights of the on-call shift at the hospital. You probably won't feel fully recovered from that sleep debt until 3-4 weeks after you're done with it, because it sometimes can take that long for your body to regain that healthy sleep. The second system is called process C, or your circadian rhythm. This is your internal 24-hour clock, which is driven by the suprachiasmatic nucleus, or SCN, in your brain. It tells your body when to feel alert and when to wind down, and this is largely influenced by light in your environment. Light is what scientists call a Zeitgeber, which means a time giver that helps to synchronize your internal clock to the outside world. And this is why jet lag or staying up late on screens will massively throw your rhythm off. Your brain gets confused about what time it actually is. While these 2 systems, the sleep pressure and circadian rhythm, are independent, they constantly interact. Your sleep pressure might be sky high after pulling an all-nighter, but if your circadian rhythm says it's daytime, then falling asleep will not be so easy. So the key takeaway here is that sleep debt isn't just about feeling tired. It's a biological imbalance that takes more than just one good night's sleep to fix. Consistent, high-quality sleep over several nights is what will truly reset the system. In other words, if you prioritize sleep, then your brain will thank you. So let's chat briefly about how sleep changes as you age. So sleep will evolve the older you get. Newborns will spend the highest percentage of time in REM sleep, about 50%, and this declines with age. Children will require more deep sleep, or that stage 3 non-REM sleep. They spend about 25% of sleep in this stage. For adults, they average about 7 to 9 hours of sleep per night, or required sleep per night, and they spend about 20% of that time in REM sleep. And with older adults, they will often experience lighter sleep, less REM sleep, and experience frequent wakening. And unfortunately, the melatonin production drops with age and decreases every decade, actually, which makes it harder to stay asleep. A quick word on melatonin supplementation before we continue. So melatonin is recommended by a sleep specialist to readjust schedules in the setting of jet lag, or if you have issues with changing your circadian rhythm in terms of, for example, if you're used to sleeping late at night and all of a sudden you want to sleep early, then you can use melatonin in those situations. It's commercially used as a sleep aid, however, but it's not recommended to be used in this way long term. In fact, in children, it's actually not recommended because melatonin can have a similar structure to growth hormone and therefore can affect development. And since melatonin is not regulated, in the US, its quality and formation can vary depending on the manufacturer. So now let's talk about sleep and how it relates to chronic disease. So sleep deprivation isn't just exhausting, it's actually dangerous for your health. There was one massive meta-analysis of about 47,000 participants and found that those who slept less than 7 hours of sleep per night actually increased your risk of heart disease. And on the other hand, having too much sleep, greater than 8 hours, was also risky as well. Poor sleep also messes with your hunger hormones. Specifically, it can lower your leptin, which is your I'm full hormone, and raises your ghrelin, which is the hunger hormone, which is the I'm hungry hormone. The result from this is that you're hungrier, you crave more carbs, and this results in weight gain, boosting appetite, and increasing your risk of obesity over time. Sleep and mental health are also deeply connected. Sleep deprivation will fuel anxiety, increase depression, and treatment for both of these issues are often fixing your sleep. Just 1 hour less of sleep will increase your depression symptoms by about 80%. And don't forget, driving while sleep deprived is also dangerous. About 20% of car accidents are actually linked to driving while drowsy without the use of alcohol. In conclusion, sleep is not a waste of time. It's essential for your brain, heart, immune system, and even your waistline. So the key takeaways here is to prioritize sleep by getting 7 to 8 hours of sleep per night, cut your screen time before bed, and respect your circadian rhythm. Remember, sleep is your superpower. If you guys liked that video, don't forget to hit the like and subscribe button for more science-backed health tips. And I'll see you guys in the next video. Bye!